Hi everyone, my name is Keith Michael Hirth. I'm the Vice President for Kaleida Health Laboratories, and I'm here today to talk about different types of COVID testing. So the first thing that I'll bring up is some questions that I've gotten from others in the past, and people saying, well, aren't all COVID tests the same? I've even had doctors say, I just want a result, and I don't really know that there are differences in the tests. And I've heard it from different people just in the community and in healthcare asking questions about the different types. To put it in a different perspective and something that's a little bit more relatable, on the screen right now, there's a whole bunch of different devices that you can loosely call computers. Now, I think everybody recognizes these devices are different and have different applications. If you're somebody that's trying to do a lot of high-end computer graphics, you're probably going to want a good desktop with a large monitor and not try to do it on a handheld. Then again, if you're sitting in an airport waiting for a flight, which none of us have been able to do recently, but if you were that person, you're going to want a handheld. You're not going to wheel a big, large lap or desktop into an airport and try to use that. All these devices do a lot of the same functions. You can do social media, you can search online, but they are different and they have their own different unique niches that they align to. This is very similar to COVID tests. Next part. Very similar to COVID tests. There are a lot of different platforms that are out there, different qualities. Some of them are made for point of care, some of them are made for large throughput or high quality, but each one of them has their own specialty niche. Each one is designed to meet a certain target and be able to be used in a different fashion. So whether it's a smaller device or a large device, each one is special in its own ways. Yes, some of them are better quality than others, but that doesn't mean one's worse off. It just depends on what you're really looking for. Some of this also, there's brand loyalty when you're talking about computers. There's also a little bit of this with COVID tests too. Some of these, because of platforms that labs currently use, they're easier to implement, easier to put in. So let's say that you're used to using an iPhone, you're probably going to stick with that, or used to using an Android, you might stick with that. Similar to us, if you're used to using a vendor, because you might already interface with them or use them, you might bring in a specific test because of that. So a lot of similarities there. So I wanted to kind of use that computer reference just to help kind of explain it. Another thing with COVID tests, though, just like with computers, there are frauds, scams, and fakes out there. So people took advantage of a pandemic. There were a lot of fake little devices that were out there, especially at the beginning of the pandemic. So this is something also to be aware of. And when you see a lot of the pop-up COVID tests that are out there, some of them are legitimate, but some of them are not either. You always have to take a little bit of caution with those. They're there to make money. That's what they're really trying to do. So just know that there are some scams out there. Getting into the actual types of tests that are on this, and we can kind of bucket them together into what do these tests tell you? What are you looking for when you're doing this? The main category, and the one that you hear about most in the media, are the diagnostic ones that tell you, am I currently infected? Do I have this virus in my system? Two main classifications in there, the antigen test and the molecular one. I'll talk about those more in a little bit, but that's your main category of tests. The next group is, have I ever had it or do I have some immunity to it? This is your antibody test. Originally, back kind of in the April-May timeframe when this test first came out, there was a lot of people utilizing it, and governments were also trying to use this to kind of see how many people in the community had actually had it at that point. Now there's some newer tests that are coming out in this field that give a little bit more information on, is the vaccine working? Do you have immunity? It's still not out there that much yet, but this is another category. I'm not going to talk about this one as much as I'll stick more with the diagnostic one. But this one is one that you might hear a little bit more coming forward, especially as we try to get a little bit more information on public immunity and the vaccine. The last category, which I won't get too much into, is the answering the question, do I have a variant? This is sequencing or targeted PCR, mostly done by state governments, academic medical centers, that are really looking at the different variants that are out there and trying to track public health. You're not going to be able to go to your doctor and say, I want to know if I have a variant at this point. It's not something that's typically done that way. Maybe in the future it will be, but at this point it's more of just public surveillance that's happening with those. Again, I'm going to stick mostly, though, with the am I currently infected, because that is the test that's widely out there and most talked about in the media. Again, with those two categories, you have the antigen test and the molecular test. The antigen test is usually done by something that's called a lateral flow assay, and that's pictured in the top left. And what that is, you get your sample and you mix it with a little bit of a solution. And what's really going on this is that there's a card that sends a sample all the way across it. So on that card, there's antibodies that'll attach to the antigen. That's the first section. You can see like the little yellow tags on there. Those antibodies have some kind of fluorescent, some kind of marker that kind of says, hey, there's something here. And then it flows across to another line of antibodies where that'll also attach. So what's kind of going on, that first set of antibodies with the markers, consider them like magnets for the COVID virus, and maybe fluorescent magnets. Those will attach to that virus as it flows across, and then it'll hit that second set of antibodies, which are a set of magnets that are stationary, and they'll stop there if you have the COVID virus. And then there's another set that's on there that kind of just tells you if that reaction actually worked. So you can see on the third set on the slide there, there's the virus that's attached on there with those little kind of fluorescent magnets at the top of it showing that it's there. In the bottom left, there's an actual picture of one of these with a pink line on it. That's kind of showing what that reaction would look like. These are pretty standard tests that are out there. They're used for flu testing, strep testing, even at-home pregnancy tests. So it's that standard, if you see 2 lines you're pregnant, if you see 1 line you're not, and it's just a standard control. Very similar test to that. That's your lateral flow assay. The next test that's out there, the molecular or sometimes called PCR test, done a little bit differently. What that is actually doing is looking for genetic material from the COVID virus. And it takes that genetic material and starts making copies of it so that you can pick it up and detect it. There is also basically a probe or a molecule in there that also gives a lot of fluorescence or gives some kind of indicator as it's making those copies, so you can actually read it and pick it up. The graph that's on there, you can see a couple different sample types. If you're starting off with more virus particles in your sample, you're going to get a signal quicker as it's making copies. Whereas if you start with lower, you'll get a signal later, but it'll always hit a threshold where it'll tell you, yes, I have the virus, or no, I do not. Consider it as if you're making copies of something and you're putting a sheet of paper through a copy machine and you can only hit copy, you can't select how many. You need 800 copies. You start off with 1 sheet, you get 1 copy, and now you have 2 sheets. You put them back through, you make copies, now you have 4 sheets. Put them back through, now you have 8 sheets. If you have to make 800 of those, it's going to take you a while. Let's say you start off with 100 copies right away. It's not going to take you as long to get to that 800 point. It's kind of what this test is doing. And in the bottom, there's a couple different varieties of this. The one with the blue cross behind it is an at-home test. And then there's a point-of-care one and a large platform that does high throughput. So this is a model that requires some equipment, but really gives you a very good result. Comparing the two a little bit more, the antigen test on those little cards, it's usually a rapid test. It's frequently a cheaper test as well. Usually requires no or very little equipment. Sometimes there's a reader with this, but otherwise it's really not a whole lot of equipment to this. It's less complex to do. You get your sample, you add a reagent, and let it go across the slide. Usually it's not a whole lot of work on that test. It's also less accurate, though. It may need to have some follow-up testing with this. I'll kind of state that follow-up testing as if you're somebody that's symptomatic, you know you've been exposed, and you have this test done and it says you're negative, you might want to go and get some follow-up and get checked out. With this test, though, there's also a small chance of false positives. So it's telling you that you're positive when you're not. So with this test, too, if you're somebody that's been very safe, you really are not symptomatic at all, and then you get a positive on this one, you might want to get some follow-up. It doesn't happen very frequently, but it does happen. The molecular test, on the other hand, it can be rapid, but it's not always rapid. It's more expensive, does require equipment, but it's higher complexity and higher accuracy on this test. And usually those do not require any kind of follow-up. With that said, there are spots and indications where you might want an antigen versus a molecular, and some where you might want a molecular versus the antigen. If you're somebody that, like I said, is asymptomatic, you've been very safe, and you need this test for work purposes where you might be going in and having to have it done multiple times a week, and you just need something for that purpose, something cheaper, you're probably going to want that antigen test. It fits that criteria for that. Or if you're just doing some basic traveling, that you're not seeing anybody that's immunocompromised or somebody that would be having a safety problem, you might want to go for this test. The molecular one, if you're symptomatic, if you're having a procedure done, or if you're seeing somebody that's immunocompromised, you might want this test because it's going to give you a more accurate result and tell you a little bit more information about what's going on. This next slide here shows some more information about when you can actually start detecting off of some of these platforms. So at the bottom left, you can see where you have an initial infection. The first yellow category that shows up on there is that standard PCR, that molecular assay of when it's picking up. And it's usually about 2 days, maybe even a little under that, that it starts picking up that you actually have, you've been infected, you have that virus in your system. It can go out past 15 days, sometimes even longer, depending on how long that virus stays in your system. So you have a long period of time where you can actually detect that. On approximately day 5, maybe even a little before, is when you start becoming symptomatic. And that's where you see that antigen test starting to pick up. Less of an area that you could pick up, but it's still pretty good in that category, and when you're kind of most infectious in that period. And then the last colors on there, the red and the green, is showing that's your antibody production. And again, I'm not going to talk too much about the testing on that part of it, but that just shows when you start producing different antibodies. And that green line shows the IgG, which is your long-term antibody, which keeps on going. That's still being studied how long you might have that antibody out there, but just kind of showing that graphed out. The main part, though, is that front section of showing the PCR molecular test having a longer period where you can actually detect with that. Another thing to mention is that the collection in this matters. There's different collection types: the nasopharyngeal, oropharyngeal, the nasal swab, and then a saliva one. Those are some of the main collection methods that are out there. Some people, if you've had the nasopharyngeal collection, you know it. It's probably one of the least comfortable ones. That swab, and you can see it in the bottom left-hand side, goes back quite a ways. I know some people that have had it, and they said it felt like somebody was swabbing the back of their head. Not comfortable, but it's a really good collection. That's where a lot of that virus particle hangs out. There's not a lot of other interference there, so it's a really good collection. If you need an accurate result, that's probably one of the better ones to go with. The oropharyngeal, and you can see that one pictured as well, it's going to the back part of the throat. A good collection as well. It's probably one of the more standard ones that are out there at this point. Again, gives you a good sample. It just can get some interference depending on if you've, let's say, taken a swallow of coffee or something like that before you've had it done. There are some things that can happen with that. The one below that is the nasal collection. Now that one can be a good sample as well, although you don't usually pick up as much viral particle as you do with the nasopharyngeal. The other problem with that is some of these at-home collection kits have you doing a nasal collection, and if you're not doing a good method with it, you're just putting it in your nose and pulling it out right away, you're probably not going to get enough particles with it, and you're going to get an invalid result or a negative result that's not accurate. There's also in the top right the saliva collection. It's a good test, a good collection method. Does have some interferences too as well. You're not supposed to drink any water or coffee or eat anything about a half hour before, so there can be some interferences with it. But really that also does give a pretty good sample. Less invasive than the other ones, although it actually takes a little bit to get enough sample in those. So I have heard of some sports teams trying to use those and feeling like they couldn't get enough sample because they were dehydrated and couldn't actually fill the cup up pretty quickly. So it took them a while. All of these are, again, like the test, they have their spot. They're good reasons why you'd want one versus the other. Again, the nasopharyngeal is probably the better collection, although it is more invasive. Oropharyngeal is also a good one. Saliva is good. Beware of the nasal one. Just you have to have somebody that really knows what they're doing in order to get a good collection with that one. Another caveat that I want to bring up with this is also with some of those scams and some of those places that are pop-up locations. Training on this is very important, especially if they're doing a nasal one and don't get enough of a sample. You're not going to get a good result. Or if they're trying to do the other ones, there have been instances where somebody's broken off a tip doing a nasopharyngeal collection or is pushed back too far because they didn't have the training for it. You really want to be going to a good location. HealthyU, we have nurses that train individuals on how to do this. You want to make sure that the training is done appropriately in order to get a good collection on this. So to conclude, not all tests are the same, but all of the tests really do have that valid purpose. They have their spot, they have their niche. So there is a really good purpose on all of them. Some of them are better quality, some of them are made more for rapid testing or being out in a field somewhere, but all of them really have their purpose. Knowing what you need should guide you in your test selection. If you're asymptomatic and you need frequent testing and you're not going to be in a risky situation, the antigen test is probably a good one. If you're going to be doing something that's having a procedure or visiting somebody that's immunocompromised, you might want more of a molecular test. The molecular test is better quality than the antigen test, but it does cost more and usually takes more time, so plan that ahead too. If you know you have travel or a procedure, make sure you're giving 72 hours for that collection, for that test to be resulted. Most places are getting them done in 24 to 48 now, but just know that it does take time. The collection is also very important. You want somebody reputable to do that collection, and keep that in mind, and also be aware of scams that are out there. At this point, I'll take any questions. I know people were putting in questions in the chat box. What are my thoughts on at-home kits? That is the first one. Some of the at-home kits are pretty decent. They'll go by, some of them are molecular tests that get sent off to a reference lab. I know some of the bigger reference labs have those out there. Again, you have to be very careful with that collection. If you don't get a good collection, it doesn't matter what the test is, you're not going to get a good result if you can't get enough viral particles. So those at-home kits, people have to really follow those directions to the T, making sure that they're doing everything appropriately. The testing on the background of that, though, usually is a good PCR test, so I'm not against them. They do fit a good purpose, too. The next question on here, a PCR test is kind of expensive. Is it worth it? I would say yes, it just depends on the situation. Again, if you're going to visit grandma and she's immunocompromised, I want to make sure that I have a good test that I know I'm not going to get her infected. If I'm having a procedure being done, I want to make sure I have a good test that I know I'm not going to infect or have something else happen to myself. There are spots where you might not need that expensive of a test, but it is a good test, and it might fit your needs, so that expense might be worth it. There are some countries, some locations that are saying you have to have a PCR test or molecular test for travel. So that might be another caveat to that as well. I think that's all of the questions that I have. So thank you very much. I appreciate everybody's time on this, and hope everybody does well. Thanks.